Dear colleagues, I will talk about modeling and water quality management using the example of eutrophication of one of the Russian reservoirs. The object of investigation is the ecosystem of the Novosibirsk reservoir, the largest one in West Siberia. The aim of investigation is analysis and prediction of long-term trends in the state of the ecosystem, including changes in the reservoir level of the example of the Novosibirsk reservoir. Novelty is synergy of structural dynamic modeling and reproduction of cycles of biogeochemical transformation for limiting elements in spatially heterogeneous ecosystem of the Novosibirsk reservoir. Model assessment of changes in internal structure of the ecosystem under intensive impacts are needed for aim. A structural change is understood as the species composition variability for links in the trophic chain in the aquatic ecosystem. Why is this being introduced? To predict long-term trends in the dynamics of water quality, changes in the biodiversity are taken into account. The structural dynamic models were appeared at the end of the 20th century. Only temporal changes have been taken into account on this path without the role of spatial mechanisms that determine the internal mass and energy flows of substances that occur in real ecosystem. Transformation and dynamics of 9 C sub I variables are simulating to reproduce the process of biogeochemical transformation of nitrogen and phosphorus compounds as well as oxygen regime in the surface and intermediate boxes. You can see list of variables on the slide. The structural dynamic modeling in assumption of full mixing explains trend of long-term eutrophication for the Novosibirsk reservoir. Previous equilibrium approaches cannot to explain this effect. The mechanism of case of unusual spatial distribution of phytoplankton is explained and evaluated on this way. Unknown parameters of the biogen model were found by minimizing CR, the Taylor's statistical criterion. Please see on slide, where n is the number of observations and x sub I and y sub I are the simulated and observed values of substances concentration respectively. It is reasonable to suppose that relatively small and low flow parts of reservoirs are more susceptible to eutrophication. In such places, the water warms up better and phytoplankton biomass is significantly higher. Depth of equatory number 5 is much less than that on number 6, through which the main part of the channel flow passes from the Ob River towards the dam. However, according to observations in August 1981, phytoplankton biomass in equatory number 6 several times higher than in number 5. Such situation is for over years too. You can see results of satellite data analysis for August 2010 in the center of slide. An increase in red color means an increase in chlorophyll A, an indicator of phytoplankton biomass. Again, the same effect. Simulation described on water exchange structure in this part of the reservoir. The dominant component of water exchange in equatory number 5 is the inflow of most part of primary production to equatory number 6. The reason of seasonable southwesterly with direction during this period. This fact is illustrated by graphs on the phytoplankton biomass variability in equatories number 5 and 6. Another paradox. Please look on the observation data for phytoplankton vertical distribution during 1981 on the right figure. Usually on June, July, September, phytoplankton biomass in the surface water layer is significantly higher than at depth because there was penetration of solar radiation here. However, please attention, in August, phytoplankton biomass at depth is greater than in the surface layer. The paradox in equatory number 9 relates to the regulating role of thermal stratification in summer. The left graph shows the calculated average water temperature in surface and intermediate boxes of equatory number 9. A steady difference in temperatures of two layers is clearly visible until the end of August. In hydrology, the lock-in effect of this phenomenon, the so-called thermocline, is well unknown. This effect means a sharp decrease in water exchange between the layers of the water column at the temperature boundary. This leads to the fact that phytoplankton rapidly developing in June quickly eats up the supply of nutrients in the surface layer. Mass exchange with an intermediate layer saturated with nutrients is locked by a thermocline. As a result, algae die-off mainly occurs in the surface layer. However, the left graph in evidence of daily temperature fluctuations in this period too. Starting from the end of June, night temperatures in the surface and intermediate layers do not differ. For short hours, the water exchange between the layers is resumed. This is enough for individual algae to get into an intermediate layer rich in nutrients. Intensive growth of phytoplankton in the intermediate layer begins just during this period. The excess of phytoplankton biomass in the water column compared to the surface layer is explained by this. This is a response on question about paradox. Forecasting the state of the ecosystem in the case of pollution control. The flushing of reservoir by a flood wave is used involved for improvement of water quality. To simulate the response of the ecosystem of the Novosibirsk reservoir under consideration in addition to the real one, the first and second scenarios for managing the operation mode in the hydroelectric power station were formed. The meaning of the first scenario option was to pass the maximum volume of water through the dam during the flood, but so that during further operation it would be possible to navigate river vessels through the Novosibirsk reservoir toward middle part of the Ob river. In the second scenario, and this restriction is removed, the maximum water level during the filling phase is such that during the subsequent low water periods were enough water for the water supply of settlements only. As a result of modeling, a detailed spatial-temporal distribution of ecosystem components in the Novosibirsk reservoir is obtained. From the huge volume of the results obtained, we will highlight the dynamics of phytoplankton content in the case of the three above described modes of the operation of the power station for the surface layers of the three water areas of the main part of the Novosibirsk reservoir and the Berdsky Bay. The sixth equatory was the most susceptible to eutrophication. An increase in the intensity of reservoir flushing due to a flood would lead to the noticeable decrease in the maximum level of phytoplankton content until 1.5 times during summer. The Novosibirsk city water intake is in the ninth equatory. Reduction of the maximum level of phytoplankton content by 1.5 to 2 times during the summer. The 10th equatory, the bird bay, is place of the birth town water intake. The implementation of the first scenario does not differ much from the real version of the temporal distribution of phytoplankton in the bird bay. However, the maximum version, the second scenario, would lead to a temporary shift of the peak of the OG content by almost a month in the 10th equatory. The reason is the difference in the rates of transformation of various forms of biogenic compounds. Conclusion. First, on the example of planktonic communities, biogenic and organic substances, the dynamics of water quality parameters in the conditions of the Novosibirsk reservoir for 1981 is estimated. Second, the influence of variability of natural factors and phenomena on water quality in the lake part of the Novosibirsk reservoir is analyzed. Wind and temperature stratification, which for example leads to unusual phytoplankton distributions at the end of summer. Third, the change in the operating mode is considered as anthropogenic factor of transformation of biogenic and organic compounds. Three scenarios of water discharge control have been formed: the real one, the first one, and the second one, according to the increasing intensity of water discharge during the flood. 4. As a result of the fight against eutrophication, the effect of a noticeable decrease in the phytoplankton biomass in the Novosibirsk reservoir was reviewed with an increase in the intensity of washing by a flood wave. 5. An increase in the intensity of flushing by a flood wave would also lead to a significant change in the dynamics of biogenic and organic substances. These would lead to a reduction in pollution by controlled parameters of water quality in some areas of the Novosibirsk reservoir in certain periods of the year, up to several times quantitatively. 6. There is a noticeable difference in the behavior of biogenic and organic pollutants in the Berdsky Bay compared to other water areas of the Novosibirsk reservoir, which indicates the feasibility of planning and implementing special computational experiments to identify difference in the mechanism of formation of water quality in the base and the main part of a channel reservoir. Then, structural and dynamic modeling of cycles of limiting elements makes it possible to study the ecohydrological mechanisms of water quality formation, including for long-term periods with changes in the level of lake and reservoir. Thank you for attention. Please, you can ask your questions and get a quick answer today and tomorrow by this email. Thank you.